Welcome to the VHDL Design and Modeling of Digital Systems course, Conditional Statements. As with classical programming languages, VHDL provides for conditional statements. These allow for the control of the execution path, which include if-then-else statements and case statements. If-then-else statements are basically structured in a priority type arrangement. If condition, then sequential statements, one or more, followed by else if condition. And else if is a keyword that provides the next level down in priority, and you could have succeeding else if condition and then sequential statements. Terminated by a final optional else, and then one or more sequential statements. We're going to show a number of examples. Here's the most straightforward one. If door is open, which is ostensibly a Boolean, if that Boolean is true, then close door, which is probably a procedure, subprogram defined elsewhere. But this shows you the basic structure of a if statement. Here we're basically adding the else option. In this case, if water is boiling state, then add pasta, else turn on stove. And that's the end of the if-then-else statement. Here we're showing the else if option. In this case, if window is closed, then open window. Else if door is closed is true, then open door. Here we're showing all the options, including a label associated with the if statement. Deal with door is the label. If door is open is a Boolean, and if that's true, then we close door and lock door. Else, if door is closed, then just lock the door. Else, we say, well, the door must be missing, so buy door, install door, close the door, then lock the door. And that's the end of our if-then-else statement. The case statement is similar to a computed goto or switch statement, which exists in other classical computer languages. The case statement syntax can start with an optional case label, followed by case expression is. Expression is basically our selector of our case statement structure, followed by when choices equal greater than. Choices is basically the different choices we can execute this subsequent sequential statements. And we can have one or more when choices statements. The case statement is terminated with the end case statement. I want to talk a little bit about choices. The syntax of choices is either a simple expression followed by a discrete, or it can be a discrete range, or it can be both. I can have simple expressions and discrete ranges, and they're separated by a vertical bar. Or we can have the keyword others. If we have the keyword others, we can't have any other types of ranges or expressions. Here's a variation of our previous if-then-else code with our door example. Case door state. So our expression is door state is when door is open. In other words, when door state is equal to door open, then we execute the following: close door, lock door. If door state is equal to door closed, then we lock door. In all other possible occurrences of or instant values for door state, we buy door, install door, close door, and lock door. Now the choices here are rather simplistic. We only have a simple expression for each of these, but we could have door open followed by a vertical bar and door closed, so that if either of those, if door state were equal to either of those, then closed door and locked door would be executed. And that would show an example of that. Here's another example of a case statement. This code shows what we might have for a case statement for determining what the next state of a state machine might be. State machine is the label. Case present state. Present state is our expression, is our selector of our case statement. When present state is equal to state 0, then we check to see if input 0 is 1, then the next state is state 0, else next state is state 1. If present state is state 1, then we go on to this second when clause, and we say if input 0 is 1, then the next state is set to state 2, else state 1, and so on and so forth. The last when statement says when others. In other words, when present state is not equal to either state 0, state 1, or state 2, then we go ahead and set next state is equal to state 0. In this last example, we have case age is when 0 to 2, we attend daycare. If we are 3 or 4, we attend preschool. If we're 5, we attend kindergarten. If we're 6 to 11, then we attend elementary school. 12 to 14, attend middle school. 15 to 18, attend high school. 19 to 22, attend college. When age is 23 to 64, we go to work. All other conditions, we retire. Beginning with VHDL 2008, the language includes two conditional variable assignment statements. These are the when else variable assignment and also the with select variable assignment, which we will see is of similar syntax to the concurrent statements, signal assignments, when else signal assignment, and with select signal assignment. Here we have two examples, and they are equivalent code. Destination colon equals, which is the syntax for variable assignment, equals, or set by the value in source 0 when selector is 0, source 1 when selector is equal to 1, source 2 when selector value is 2. Otherwise, we set destination with source 3. Now, the with select syntax, it's a bit cleaner for a mux. We say with selector select, and then destination colon equals source 1 when 0. In other words, when the value of selector is 0, we set destination to source 0. We set it to source 1 when selector is 1. We set it to source 2 when selector is 2. And we set it to source 3 for all other values of selector. The null statement provides us with a way to say that nothing is to be done at this point in the code. The syntax is simply optional label followed by the keyword null. Here's an example. If command is equal to escape, then execute get out of Dodge, else null. Now, strictly speaking, the else null really isn't needed, but sometimes we use the null keyword to basically provide ourselves a placeholder for a place where we expect to put code in later, or just to highlight the fact that nothing will be done in case that command is not equal to escape.